Hello, it's Mrs. Plenda again, and today's lesson is about solving equations and inequalities. Because you may not have solved inequalities before, we're only going to talk about two steps today. We're going to work our way up to the more complicated equations a little bit later. But today I want to make sure we've got these two-step equations and inequalities all set. So the first thing that we need to talk about when we are solving is how we undo the operations that we see in the equation or inequality. So we undo them using inverse operations. Inverse operations are opposites. So can you think of any? All right. If you are thinking addition and subtraction, absolutely. Addition and subtraction are opposites. They undo each other. If I add 5 and then subtract 5, I'm back where I started, right? Those two have canceled each other out. Multiplication and division are also inverse operations. And of course, there are squares and square roots, also inverse operations. So these are the ones that we'll be using in Algebra 1. There's a couple more you'll see later, but these are the ones we want to focus on for solving our equations and inequalities. So one of the other things that we think about is because we are working backwards, what order do you think that we'll do our operations in? If normally we follow our order of operations, when we're solving and moving backwards, we'll go in the opposite fashion. So when we solve, we tend to add, subtract, then we multiply, divide, and we usually deal with exponents and groups last, okay? So solving is working backwards, so it also processes through your order of operations backwards. We're peeling away the parts to get to the unknown variable that we're looking for. The other important thing that we need to keep in mind is that we must keep our equation balanced. The equal sign in an equation means that both sides are exactly equal weight, kind of like a scale, right? So whatever we do to one side of the equation, we must also do to the other side of the equation. For example, if I'm taking a look at this scale and I want to get just that x on one side, that means I would take away these 3 circles. So on the other side, I will also have to do exactly the same thing and take away 3 circles. So whatever we do to one side, we must also do to the other side. Okay? So let's go ahead and take a look at some examples. Since we know that we are going to add, subtract, we will make sure that we are taking a look at that first. So let's take a look at this first problem. I've got 2x plus 3 equals 7. So since it says plus 3, the opposite of plus 3 is subtracting 3, so I will subtract 3. And because I did it on one side of the equals, I must do it on the other side of the equals. And then I'll go ahead and resolve that step, right? So I still have the 2x, I didn't do anything with it. Plus 3 minus 3 gives me 0, so that is gone on that part of the equation. And 7 minus 3 gives me 4. So now I have 2x equals 4. Well, the 2 and the x right next to each other are multiplying, so I need to do the opposite. I need to divide. So I will divide by 2 on this side, and the other side of the equals, I will also divide by 2. Then I'll go ahead and resolve that step. So 2 divided by 2 is 1, so I have just 1x left over. And 4 divided by 2 gives me 2. And now I can see that x is equal to 2. All set. Let's go ahead and take a look at the second example. Let's see if I can find a different color for that one. Okay, so here I've got x divided by 2 minus 1 equals 5. So again, we're going to add, subtract first. So since the problem is already subtracting, I want to add. So it says minus 1, I'm going to add 1. And because I did it on one side of the equation, I must also do it on the other side. You guys may have drawn like a railroad tracks down that before to make sure that you do it on each side. That's totally fine. It's a great tool to keep you organized. I'm going to go ahead and resolve this step. So I still have the x divided by 2 because I haven't done anything about that yet. But minus 1 plus 1 cancel each other out. I just have 0 there now. And 5 plus 1 will give me 6. Now I've got x divided by 2. The opposite of division is multiplication, so I will multiply by 2. And because I did it on one side of the equals, I must also do it on the other side of the equals. So multiplying by 2 and dividing by 2 are inverses. They will cancel each other out. I'd end up with just 1x. And 6 multiplied by 2 gives me 12. So I can see that x is equal to 12. Okay? So those are the equations that you probably have seen before. Today we're going to talk about inequalities and how they are just a little bit different. Okay. Now, if you don't remember, inequalities are these little symbols that mean like not equal in one way or another, right? We've got greater than, less than, greater than or equal to, and less than or equal to. They each have their own symbol. If it is equal to, it will also have a line underneath. Okay, so greater than or equal to also has a line, less than or equal to also has a line. So it's like they took the greater than symbol and an equal symbol and they put them together into a single symbol. If they are equal to, our circle will be filled in when we graph it. If they are not equal to, our circle will be open. Okay, so let's go ahead and talk about solving an inequality. Solving inequalities is very much like solving equations. We're still going to use our inverse operations on both sides of the symbol, and we're still going to work our way backwards. There's one important difference we need to keep in mind when we solve inequalities. When we multiply or divide by a negative number, we have to flip the inequality sign. Okay, so I've got a short little example right here. Let's take a look at it. So I've got negative 2x is greater than 6. Because I am multiplying the negative 2 and the x, I will do the opposite, which is to divide by that negative 2. But because I am dividing by a negative 2, instead of leaving the inequality sign like it is, I need to flip it around. Okay? So that means instead, for my answer here, when I write it, instead of having x is greater than, it will be x is less than negative 3. Okay? And the reason that we have to flip this around has to do with the way that our number line works. You see, when we have 3 is less than 7, right? We could definitely see that when we go from 3 to 7, that's an increase. But if we multiply that and flip it to the other side of our number line, I've got negative 3 and negative 7. When I go from negative 3 to negative 7, I'm actually decreasing instead of increasing. So when we have to flip to the other side, when we multiply it by that negative 1, our relationship between the numbers flips around, and that's why we also flip our inequality sign. So let's do a couple examples. So I've got an example, 1/3 x plus 3 is greater than or equal to 7. So just like our equations, we're going to make sure that we do our adding, subtracting first. So since it says plus 3, I will subtract 3. And I'm going to have to do that on both sides of my symbol, just as if it was an equal sign. In fact, this one is greater than equal to, so it does have an equal to contained within it. Okay, so then I'm going to resolve that step. So I've got 1/3 x, because I didn't do anything with that yet. Plus 3 minus 3 gives me 0, so there's nothing on that side now. And 7 minus 3 will give me 4. Okay, still have the symbol facing the same way. Because I have 1/3 x, remember that fractions are the same thing as division. That actually means x divided by 3. So I'm going to multiply by the number on the bottom, the denominator. So I will multiply by 3. That will be the inverse of taking 1/3 of x. And because I did it on one side, I must also do it on the other side. These are positive numbers, so I don't need to worry about flipping my sign. 3 times 1/3 gives me just 1x, which is what I'm looking for. I'm not flipping my sign because there's no negatives in that multiplication division step. And 4 times 3 gives me 12. Now, the other important thing, as I have noted on this slide, is that we must graph our answers, because it's not just x is equal to 12, it's x is greater than or equal to 12. So I need to think about this on my number line. So let's go ahead and give ourselves a nice little number line here. And I'm thinking about this value being equal to 12, but also being greater than. So I need to have some numbers that are also greater than 12. And when I'm graphing my answer, I'm not going to include just 12 because the answer is not just 12. It is, in fact, greater than 12. Okay, so that means that it is equal to, so I will have a solid circle. It is equal to, so I will have a solid circle on the 12. But it's also greater than, so my arrow needs to point to the numbers that are also bigger than 12, so we will go this way. And show that this x is not just 12, it could be 13, it could be 14, it could be 12 and a half. We just know that it's equal or greater than 12, and so our graph needs to show all those possible values. It's an entire range of values instead of a single one. Okay, let's go ahead and take a look at our second example. So our second example is showing negative 3x plus 4 is greater than 10. Just like our equations, we will add subtract first. So since I see plus 4, my opposite, my inverse operation I'm going to use will be negative 4. So subtract 4 and subtract 4. Both sides of the symbol, just to keep it, the statement the same. So then I'll resolve that. I have negative 3x is greater than 6. And now for my next step, because negative 3x is multiplying, I'll do the inverse or divide by negative 3. Now here's our sign. I am dividing by a negative number, so that means that I will need to flip this sign when I resolve. So that means I've got x, flip, less than now, negative 2. And just as before, we're going to go ahead and graph this. So we need to make sure that we are showing the entire range of possible values for our answer, not just the single value. And because 2 is sort of my focus here, I'm going to go ahead and drop, negative 2 in the middle. So negative 1 will be up here as the higher value, and negative 3 will be down here as the lower value. Now in this case, x is not equal to 2. So for this one, I will have an open circle to show that the negative 2 is not actually included. And my x is less than, so I need to go to the left to the lower values. And so my arrow will go this way to show that the lower values are part of my range, part of the answer there. There we go. And there's our first two inequalities solved. Let's do a couple a little bit more complicated. Looking at these two problems, they don't look very different from the ones we just did. So let's go ahead and start with the left one and start with that opposite of adding, subtracting, just like we normally would. I've got 5x minus 1, so the opposite is to add 1 on both sides of our symbol. 19 plus 1 will give me 20, greater than or equal to 5x. And minus 1 plus 1 are opposites. They cancel each other out. I just have the 5x there now. So my next step would be to go ahead and divide. 5x means 5 times x, so the opposite of multiplying is dividing. I will divide each side by that 5. 20 divided by 5 is 4, greater than or equal to, and now I have just x on that side. So our solving steps looked exactly the same, but I notice when I'm looking at my answer now, the x is on the right instead of the left, and we haven't graphed them with the x on the right. So what I'm going to do is I'm going to take this expression and I'm going to flip it over so that the x is on the left instead. So here's my x, here's my 4. Now keep in mind, your symbol has to be saying the same thing. Up above, it's saying that the x is the smaller part. So I need to say the same thing down here. The x is the smaller part here. It's less than or equal to the 4. So in order for our symbol to say the same thing, if I move the x to the other side, the symbol must also move with it to say that it's still the smaller piece for this particular example. And we, of course, need to graph it because it's an inequality problem. So here's my number line. We are focusing on 4, so I'll put that in the middle. 5 is bigger, 3 is smaller. Will I have an open circle or a closed circle? Okay, we will have a closed circle because it is equal to. And because the x is less than, we will go to the left. To the lower values, we go left. There we go, all set. Let's go ahead and take a look at this last one. So this one has some parentheses, which can be a little bit scary, but one thing that we can remember, when we've got that 3 next to the parentheses, that actually means the 3 is multiplying with whatever's inside the parentheses. So since we're working with inverse operations today, what's the inverse of multiplying? Dividing. So let's go ahead and divide by 3 on both sides of the equals. So let's divide by 3 here and divide by 3 here on this side of the equals. So multiplying by 3 and dividing by 3 are opposites, so I'll have just 1 there, which means I've got just the m minus 7 left over, and since there's no multiplying, I don't need the parentheses anymore. And 24 divided by 3 is 8. There we go. So we sort of divided first and our group kind of went away, which is nice and convenient. Now I see m minus 7, so the opposite of subtracting is adding. Got to do that on both sides of the equals. So then resolving that, I have m is equal to 15. And because it is an equation with an equal sign, we don't have to graph that because it's not a range of numbers for our answers. Our answer is just 15. M is equal to 15 and nothing else. Okay. So those are equations and inequalities, just 2 steps. That's all there is to it.